Hey guys, it's Layla. Today we will speak about the formula and the steps for rehydration in pediatrics. The amount of fluids that you need to instill in a child depends on certain factors. This fluid that you instill is divided into two types of solutions. So you have the glucose solution and then you have the physiological saline. If the patient requires potassium, you will infuse it into the glucose solution, and if the patient requires sodium, it is a part of the physiological saline. Saline is sodium chloride. Fluids need to be administered for three reasons. The first one is pathological losses. So if you have diarrhea or vomiting or polyuria, basically the fluids that you lose due to a pathology. The second one is daily requirements. How much water or fluids you need on a daily basis, depending on your weight. And the third one is current losses, the amount of fluids you lose due to involuntary activities such as breathing, such as sweating, etc. Before we learn how to calculate the different requirements, let's look at the different stages of dehydration. There are three. The first one is mild, and it includes fluid loss up to 5%. The second one is moderate, which includes fluid loss up to 10%, but after 5, so 6 to 10. And the last one is severe, which includes fluid loss more than 10%. But for the sake of calculation, for mild we use 5%, for moderate 10%, and for severe 15%. Let's start calculating the loss of water due to a pathology. The formula is 10 times the weight of the patient times the percentage of dehydration. Let's say we have a 5 kilo patient that suffers from mild dehydration. So 10 times 5 times 5, which is 250 mils of water lost due to a pathology. If you have the age of the child but not the weight, you can use these formulas to calculate the weight of the child in kilograms. If the child is an infant, use the formula age in months plus 9 divided by 2. If the child is 1 to 6 years, you will use the age in years plus 8. And if the child is more than 6, you will use the age in years plus 10. For example, if I have a 3-month-old baby, the weight will be 3 plus 9, 12 divided by 2, 6 kilos. Moving on to the daily requirements. For the first 10 kilos, the daily requirement is 100 mils of water per kilogram. From 11 to 20, you have plus 50 mils per kilogram. And beyond 20, you have 20 mils per kilogram. For example, if you have a 5 kilo patient, their daily requirement will be 500 mils. If you have a 12 kilo patient, so you have 10 times 100, which is 1,000, and then 2 times 50, which is 100. So in total, 1,100. For current losses, we take a standard value of 100 mils. Now that we are done with water, let's look at the different requirements for sodium and potassium. For sodium, for pathological losses, in 100 mils of water, we have 6 or 8 millimoles of sodium. So when we find out the amount of water that is lost from our body, so the pathological losses of water, we are able to calculate the sodium. For example, if a patient has lost 200 mils of water, that means they have also lost 12 millimoles of sodium. For potassium, in 100 mils of water, we have 2 or 3 millimoles of potassium. So if we lost 200 mils of water due to a pathology, we have also lost 4 millimoles of potassium. For daily requirements, we need 3 millimoles of sodium per kilogram. and we need 2 millimoles of potassium per kilogram. So, for instance, if our patient weighs 5 kilograms, we will need 15 millimoles of sodium and 10 millimoles of potassium. Just like we had a standard value for current losses for water, it is the same with the electrolytes. So, a standard value of 6 or 8 millimoles for sodium and 2 or 3 millimoles for potassium. Now that we know how to calculate the requirements, let's learn how to instill the fluids. We have 3 phases of rehydration. In the first phase, you will only give half of the volume of pathological losses. In the second stage, you will give half of the value of the pathological losses and a third of the daily requirements. And in the final phase, you will give 2/3 of the daily requirements and the current losses. For example, I calculated my pathological loss to be 200 mils. So in the first phase of rehydration, I will only give 100 mils, only half of that. And in the second phase, I will use the rest of the 100 from the 200 mils that I calculated for the pathological losses. Remember, I told you when you instill fluids, you give it in glucose and saline solutions. So how to calculate the physiological saline from the total fluid that you need to give? In 100 mils of saline, we have 15 millimoles of sodium. So when you calculate the amount of sodium that you need to give the patient in the first phase, you can automatically calculate the saline value. Now, in order to find out how much potassium to infuse in the glucose solution, you need to know that 1 ml of potassium chloride solution contains 2 millimoles of potassium. So when you calculate how much potassium you need to instill in the patient, then you can automatically calculate how many mils of potassium chloride you would like to infuse into the glucose solution. I know, it probably feels like too much right now and you probably want to cry. But once you do a couple of practice questions, it will all make sense and it will be easy, I promise. Alright, let's do a question together. So we have a 6-month-old baby with mild dehydration. I would recommend all of you to make a table like this. 1 for water, 1 for sodium, 1 for potassium, showing the different requirements, so pathological, daily, and current. Then you can just calculate and fill in the table. Always start with the current losses because that's something you know. We have standard values, so 100, 8 and 3. I will take 8 and 3 instead of 6 and 2. Then we can move on to the pathological losses. How do you calculate that? Do you remember? 10 times the percentage of dehydration times the body weight. We do not have the body weight over here, so we need to calculate that. Do you remember how to calculate the weight of the child? 6 months, so that is an infant. So 6 plus 9 divided by 2. That is 15 divided by 2. That would be 7.5. You can either take 7 or 8. It's up to you. I will take 7. So 10 times 5, which is mild dehydration, so it was 5%, and then 7, which is the weight of the child. So the total is 350 mils of water has been lost due to a pathology. Okay, moving on to sodium. In 100 mils of water, we have 8 millimoles, 6 or 8 millimoles of sodium. So I'm going to take 8. That means if we have 350 mils of water that is lost, we have also lost 28 millimoles of sodium. For potassium, in 100 mils of water, we have 2 or 3 millimoles of potassium. I'm going to take 3 as I did with the current losses. So in 350 mils of water lost, we have also lost 10.5 millimoles of potassium. You can just take it as 10 or 11. Moving on to the daily requirements. We need 100 mils per kilogram. Now our patient weighs 7 kilos, so it will be 700 mils. For sodium, we said 3 millimoles per kilogram, so 3 times 7, 21. For potassium, we said 2 millimoles per kilogram, so 2 times 7, 14 millimoles of potassium. And now we have finished the table. Okay, let's start the rehydration. So for the first phase, we only use half of the pathological losses. So we got 350 mils of fluid to be instilled, so we will give only 175 mils of water or fluids. For sodium, we had 28, so we only need to give half of that, which is 14 millimoles of sodium. We do not give potassium in the first phase of rehydration because the patient is anuric or oliguric. Now we have to split this amount of fluid that we have, 175 mils, into physiological saline and glucose solution, right? So starting with saline, we have our formula. In 100 mils of fluid, we have 15 millimoles of sodium. So now we need 14 millimoles of sodium. So just multiply 14 with 100, divide that by 15, and you will get your value. That would be 93 mils of saline. Now we have 93 mils of saline, so subtract this by the total amount of fluids that we need to instill in the first phase, which is 175, 81.6 or 82 mils of glucose solution. Moving on to the second phase of rehydration, we need half of the pathological losses and a third of the daily requirements. For water, we have 175, which is half of the pathological, and a third of the daily, which is 700, would be 233 mils. So in total, we have 408 mils of fluids to be delivered. Now for sodium, we have half of the pathological, which is 14 millimoles, and then we have a third of the daily requirements, which is 7. So 14 and 7 becomes 21 total millimoles of sodium is required. Let's calculate the physiological saline. How did we do this? We have to multiply the amount of sodium that we need, which is 21 times 100 divided by 15. So we get 140 mils of physiological saline. Now subtract this by the total amount of fluids that we need for the second phase, which is 408, and we have 268 mils of glucose solution. In the second phase, we will infuse potassium chloride. So half of the pathological losses will be half of 11, 5.5, a third of the daily requirements, which is 14 divided by 3, that will give you 4.6. So we need a total of 10 potassium chloride to be infused. Now remember, we said 1 ml is 2 millimoles of potassium, so now we need 10 millimoles. That means we will infuse 5 mils of potassium chloride into the glucose solution, into the 268 mils of glucose solution. Moving on to the third and final phase of rehydration, we need 2/3 of the daily requirements for water and the current losses. So 2/3 of 700 is 467 mils, and the current losses is 100, so the total is 567 mils of fluids to be instilled in the third phase. For sodium, 2/3 of the daily requirements will be 14 millimoles, and for the current losses is 8 millimoles. So 14 and 8 is 22 millimoles of sodium is required. Use the formula again, 22 times 100 divided by 15, 147 mils of physiological saline. Now subtract this from the total amount of fluids, and the glucose solution will be 420 mils. For potassium, 2/3 of the daily requirements will be 9 millimoles, and the current losses will be 3 millimoles, so a total of 12 millimoles of potassium needs to be infused, and that means that is 6 mils infused into the glucose solution. Alright guys, I hope it was clear. I'll see you in the next video. Take care, bye!